Hello, everyone. So today we'll talk about the intermediate value theorems and do some exercises on this. So, what does the intermediate value theorem state? As we have seen in class, it says that if f is a continuous function on the interval ab and m is a number between f of a and f of b, of course, we're assuming that f of a and f of b are distinct, then we can find the c in the interval ab such that f of c is equal to m. Now, to illustrate this graphically, I have drawn the graph of a continuous function on the interval AB, and I took the point A f of A on this curve and B f of B. So f is continuous because technically I did not lift the pen when tracing the curve. And let us see what the intermediate value theorem states. So m is a number between f of a and f of b. So if I pick m to be a y value between f of a and f of b, the intermediate value theorem states that there exists a c inside the interval ab such that f of c is ab. This means that if I take the line y is equal to m, this horizontal line, the intermediate value theorem will say that the line y equal m will intersect the curve y is equal f of x in at least one point. Now, in order to see that, we have many points here that are possible. This point, this point, this point, this point, and this point. So really, that C may not be unique, but what we know is that there exists one. Now let us move on to applications of the intermediate value theorem and use it to solve some questions. So first of all, let f of x be 4x cubed minus 6x squared plus 3x. Show that there exists a number c in the interval 1, 2 such that f of c is equal to 2. Of course, the way to proceed here is using the intermediate value theorem, classic question. So in order to check that, I first need to check that f is continuous on the closed interval 1, 2. Here I have open. So f is continuous on the real line, which is minus infinity to infinity, since f is a polynomial. This is the first thing to check if my function is continuous. It's a polynomial, and polynomials are continuous on their domain, which is the real line. Now, what is f of 1? F of 1 is 4 times 1 cubed minus 6 times 1 squared plus 3 times 1. So it's 4 minus 6 plus 3. What is that? So it's minus 2 plus 3, which is 1. What about f of 2? F of 2 is, let's see, 4 times 2 cubed minus 6 times 2 squared plus 3 times 2. What is that? This is 4 times 8, 32, minus 24 plus 6. What is that? This is 8 plus 6, which is 14. Well, now that I have f of 1 and f of 2, the question here is that does 2 lie in between f of 1 and f of 2? And the answer is yes. So f of 1 is bigger than 2. Smaller than 2. And f of 2 is bigger than 2. Now, since 2 is between f of 1 and f of 2, then by the intermediate value theorem, there exists c in the interval 1, 2 such that f of c is equal to 2. It's very important to state all the assumptions that f is continuous on the real line, So it's continuous technically on the interval 1, 2 as well, right? And on the closed interval 1, 2. It's very important that the interval here is closed. Okay? And then show our work by computing the value of f at f of 1 and f of 2, and that if the value that we're looking after, in this case it's 2, lies in between the f of 1 and f of 2, then this solves the question for us by using the intermediate value theorem. Okay, let's move on to a slightly complicated question. So show that there exists a solution to the equation x cubed is equal to 3x minus 1 in the interval 0, 1. This is also almost a similar type of question, but I mean here, what do I need to do before I approach this? I just have to note that x cubed, a solution to x cubed is equal 3x minus 1 is a root, well, a solution is a root of f of x is equal x cubed minus 3x minus 1. Why is that? Because, solving x cubed is equal 3x minus 1 is equivalent to solving x cubed minus 3x minus 1 is equal to 0. And here it's just x cubed minus 3x plus 1. Since. So really, I'm looking to check whether f has a root, f of x has a root in the interval 0, 1. So looking for a root of f of x in 0, 1. And a root is a function, is a value of x at which the function assumes the value is 0. So really I'm looking for the solutions of f of x is equal to 0. Great. I mean, so if f of x is x cubed minus 3x plus 1, f of x is a polynomial. So f is a polynomial function. And hence continuous. We'll say on 0, 1. I mean, it's continuous on R, but it's also continuous on 0, 1. Now, what is f of 0? F of 0 is just 0 cubed minus 3 times 0 plus 1, which is 1. And f of 1 is just 1 cubed minus 3 times 1 plus 1. So it's 1 minus 3 plus 1, which is minus 1. Now, does 0 lie in between f of 0 and f of 1? Yes. Of course, here f of 1 is smaller than f of 0. So f of 1 is less than 0, and f of 0 is bigger than 0. So by the intermediate value theorem, there exists a c inside the interval 0, 1. Here we can take it the open interval, such that f of c is equal to 0. We can take the open interval because 0 is different than 1 and is different than minus 1. Anyways, such that f of c is equal to 0. Now, if I have f of c is equal to 0, then I have that I have a solution, and hence c is a solution to x cubed is equal to 3x minus 1, and c belongs to 0, 1. Here it's very important every time to define the function. Put everything on the same side and define the function. And state or prove that the function is continuous, and then apply the intermediate value theorem. Okay, great. Let's move on to one more question. So let f of x be x plus cos x. Show that there exists a real number c such that f of c is equal to 0. I mean, here there are many ways to proceed, but, well, technically, most of the ways involve the intermediate value theorem. But anyways, let's try to do it in a classical way. Here I'm not given the interval AB. We're not given the interval. So what we gotta do is that we have to find it. Now, since f of x is continuous on R, right? F is defined on R. F is continuous since the functions x to x that sends x to x and, well, that sends x to cosine x are both continuous. Basically, the identity function, which is x, and the cosine x are both continuous on R. So really, I can apply the intermediate value theorem, provided, so here I need to find the interval. We need to find the interval. So we have to find an interval or a number which in that at which f takes a negative value, and a number to which f takes a positive value. Now let us look at f of 0. F of 0 is, I mean, let's plug in easy numbers. 0 plus cos 0, which is 1. So f of 0 is 1. Now let us try to find a negative number. Or a number at which f is negative. I mean, let's try to look at this. Here, technically, if I plug in f is equal minus pi over 2, what happens? I get minus pi over 2 plus cosine pi over 2, which is minus pi over 2. Of course, also other number would work. I mean, if you can take f of minus pi, for example, you get minus pi minus 1. That's another way to do it. But anyways, we have used this. So f of minus pi over 2 is negative, and f of 0 is positive. Hence, since f of minus pi over 2 is less than 0, which is less than f of 0, then by the IVT, there exists a C in the interval minus pi over 2, 0, such that f of C is equal to 0. And that really solves the question. I mean, you can also sketch the graph. It's not a, well, it's not the easiest graph to sketch, but it's not a hard one either. Okay, so here it's important that we are finding the interval, so we have to make a guess on what numbers to plug in. Now, it may be hard at first, but with practice, I think you can find the better ways to plug it in. Of course, there's another way. I mean, for now, let us take